A rigid vessel of volume 0.5 meter cube contains hydrogen at 20.5 degrees Celsius and a pressure of 611 into 10 to the power 3 pascals. Is connected to a second rigid vessel of volume 0.75 meter cube containing argon at 31.2 degrees Celsius at a pressure of 433 into 10 to the power 3 pascals. A valve separating the two vessels is opened and both are cooled to a temperature of 14.5 degrees Celsius. What is the final pressure in the vessels? Let's analyze what the situation is like. Let's say this is our container number 1. There is a valve in here and this is our container number 2. Okay. The container number 1 has a volume of 0.5 meter cube and it has hydrogen which is at a temperature of 20.5 degrees Celsius and pressure of 611 into 10 to the power 5 pascals. And at the same time, the second rigid vessel is having a volume of 0.75 meter cube and it contains argon. It is at a temperature of 31.2 degrees Celsius and the pressure is 433 into 10 to the power 3 pascals. Now what they are saying is that you open this valve. When you open this valve, what the figure would become is this, that now the gases can mix. So when the gases can mix, you can say that the final volume of the container is the sum of the individual volumes, that is 0.5 plus 0.75, which is 1.25 meter cube. This becomes the final volume of the container that both the gases are going to occupy. And we can also say that the number of moles final will be the number of moles initial plus number of moles of the gas to initial. The temperature final is given to be 14.5 degrees Celsius, which can be written as 287.5 Kelvin by adding a 273 to this. We have to find the final pressure, correct? So let's plug in our values into the equation PV is equal to nRT. But for that, we would require what is N1 and N2. So first of all, let's find out N1 and N2. N1 is given by P of H2 into V of H2 by R into T of H2. N2 is given by P of argon, V of argon divided by R, T of argon. And when we add both of these in the final equation, we can say that the final pressure into the final volume divided by R into the final temperature is equal to N1 plus N2, which can directly be written from this. So let me write this equation as this plus this, and to simplify things, we remove N2 from here and N1 from here. We know that these are N1 and N2. So this is basically our equation. R gets cancelled out, correct? We need to find P final. So let's just plug in all the values we have. PH2 is 611 into 10 to the power 3 into VH2 is 0.5 divided by TH2 is 20.5 degrees Celsius. What would it be in Kelvin? 273 plus 20.5, it comes out to be 293.5 plus P of argon is 433 into 10 cube. V of argon is 0.75 divided by temperature of argon will be 31.2 plus 273, which comes out to be 304.2. Now this is equal to P final into V final is 1.25 divided by T final is 287.5. So let's solve the left hand side first. we have to multiply 611 by 0.5 and divide it by 293.5. This comes out to be 1.04 into 10 to the power 3 plus 433 multiplied by 0.75 divided by 304.2. This comes out to be 1.06 into 10 to the power 3. So adding these, we get it to be 2.1 into 10 to the power 3. Now we actually have to multiply this 2.1 into 10 to the power 3 by 287.5 and then divide it by 1.25. So the answer on doing these operations comes out to be 483 into 10 to the power 3 pascals. So if we look at our options, 483 into 10 to the power 3, we'll have to shift the decimal to 2 places towards the left. So it will be 4.83 into 10 to the power 5 pascals, which is approximately option D.